Okay, let me show you how to write ionic and net ionic reactions based on this equation given, where we have lead nitrate reacting with potassium iodide to form potassium nitrate and solid lead iodide. Now, when we go about writing our first full ionic equation, we want to decide, are we going to dissociate each of these compounds or do we leave them intact? So the basic rule is the following. We're going to go ahead and split any compounds that are ionic, composed of usually a metal and a nonmetal, and those ionic compounds have to say aqueous. If they're dissolved in water, then they dissociate. The second rule is that we're going to split any acids that we deem are big 7 strong acids. We're going to know it's an acid because it starts with H. We'll know it's a strong acid, a big 7 acid, if it's one of the 7 on our list of strong acids. Clipper, clo, clo, no, so. So, if it's a ionic with an AQ or a big 7 acid, split it. Otherwise, we leave it alone. So let's begin. So I'm going to go ahead and take a look at this first compound shown, lead nitrate. Lead nitrate starts with a metal and a polyatomic ion. It is ionic. It also says aqueous. So since it's ionic and aqueous, we're going to go ahead and split it into the positive and negative ions that it contains. We're always going to split these into just 2 pieces, never more than 2. So the first positive piece happens to be the lead. The negative piece happens to be the nitrate. Now, when I look at those charges, it's incredibly important to write the charges of each. They are ions after all. The nitrates happen to be minus. I happen to have 2 nitrates in this compound, so I'm going to put a 2 right in front of the nitrates. Then, because there is 1 lead with 2 NO3 minuses, I know the charge of the lead ion happens to be a 2 plus. So, lead nitrate breaks apart into 1 lead and 2 nitrates. I'm going to put a little plus there. They're now separated. Now, we're going to go ahead and take a look at our second compound, potassium iodide. Potassium starts with a metal. We have a metal and a nonmetal, so we are ionic. It also says aqueous, so we're going to split this apart into the component ions. The 2 ions for lead iodide are K with a plus and iodine with a minus. Now, a single Ki would give us 1 K and 1 I. However, we have 2 potassium iodides, so we're going to get 2 K plus ions and 2 I minus ions. Okay, so far so good. We split lead nitrate into plus minus, potassium iodide into plus minus. Now we'll draw our arrow. Let's look at potassium nitrate. We have a metal and a nonmetal polyatomic ion. So since it's ionic and since it has an AQ, aqueous, we're going to split it up into the 2 plus and minus pieces. The plus piece is our potassium with a plus charge. Now, I've got from each potassium nitrate 1 potassium, but if I have 2 potassium nitrates, I have 2 potassiums. Plus, nitrate is going to be my minus piece. Nitrate is an NO3 with a minus charge. Now again, this is probably one of the easiest things to mess up on. If you had 1 potassium nitrate, you would get 1 potassium and 1 nitrate, but you have 2 potassium nitrates, so you're going to get 2 nitrates out of that. So we split up potassium nitrate as well. Now let's look at our last piece. Now we have lead iodide solid. Lead iodide is ionic. We have a metal and a nonmetal. However, this does not say aqueous. It's in its solid state. So when you have ionic compounds in their solid state, do not split them up. Leave it alone. We're just going to go ahead and recopy this down. PbI2 as a solid. Okay, now what I have here is the full ionic equation. Everything is written the way we find it in solution for this particular reaction. Now, if we want to take this full ionic equation and change it into what we call a net ionic equation, what we're going to do is we're going to look for compounds or components here, ions, things that are exactly the same on the left-hand side of this equation as on the right-hand side of this equation. So when I look at my equation, I notice that I have two K pluses on the left of the equation, and I also have two K pluses on the right-hand side of the equation. If we have the exact same things on both sides of the equation, like in algebra, we can cancel them out. Now, what this means is that potassium did not do anything in this reaction. I had two K pluses floating around at the beginning. I had two K pluses floating around at the end. It did not participate in the chemical reaction. I call those things spectator ions. They just simply watched the reaction happening. So one of my spectator ions is potassium. The other spectator ion is nitrate. I have two nitrates on the left. I have two nitrates on the right. I can also cancel those out. They are also spectator ions. What I'm left with is the things that actually reacted during this reaction. Lead 2+ reacted with two I- to form PbI2 as a solid. I'm going to come down here and write that. Pb as a 2+ ion in solution. I started off with Pb from solution. This was Pb2+ aqueous. I'm going to go ahead and carry that through right now. So Pb that was aqueous became Pb2+ that was aqueous. Here it is here. Plus the iodides. I have two I- that originally came from an aqueous solution. I'll write that down right here. Those two formed lead iodide as a solid, PbI2 as a solid. Now, when you get done, what this is, your net ionic equation, I'll write that here, net ionic equation, shows what actually participated in this reaction. Lead 2+ in solution reacted with two I- in solution to form lead iodide solid. Now, one thing I want you to always double check before you're finished. Make sure your net ionic equation is balanced, both for elements, one lead, two I's, but it needs to also be balanced by charge if you've done it correctly. So here I have a +2 charge from my lead. I also have two -1 charges from the iodine. So I also have a -2 from all of my iodines. 2 times -1 is -2. That equals 0 on the left-hand side of the equation. On the right-hand side of the equation, I don't see any charge shown, so that is also 0. My equation is balanced not only by elements, but also by charge. That's a really good way to double check your answer. I hope that helps. See you in the next examples.